In this video we are going to start a new topic, that is stability, which is very important in GATE point of view. For any other technical exams also this topic is very important. Stability or stability analysis is this topic. So we are having so many important points, each and every point, theory point which I mentioned here is very important. Based on each and every point listed here, you are going to get some questions, you are going to solve some questions. So all these points are very important key points to solve so many big problems. So here the first point is a system is stable if its input is bounded and output is also bounded. For a bounded input, if you are getting bounded output, then the system is said to be stable. Then you will get some doubt, what is meant by signal bounding? What is meant by a bounded signal? Bounded signal is nothing but finite signal, or for better clarification, bounded signal is nothing but the maxima and minima of the signal must be finite. So you will have maxima and minima in the signal. If your maxima and minima of your signal is finite, so you can say all the values in the signal are finite. So then we can say that is a bounded signal. For example, I will give you some so this is a bounded signal. So this is a bounded signal. Why? Because so the maxima is having some finite value and minima is 0. So these two are finite. So we can say this is a bounded signal. So this is bounded signal. For example, if you are having ramp. So if you are having ramp, so the minimum value of ramp is 0 volts and maximum we don't know. At t is equivalent to infinity, you will get some infinity. So here the maximum value is not finite, only minimum value is finite. In this case the signal is said to be unbounded. So this is unbounded signal. Coming to another signal like this, if you are having signal like this, the minimum amplitude is finite, but the maximum amplitude we don't know. This is continuously exploding, continuously rising signals. So generally continuously rising signals are said to be unbounded signals. So here also we can't trace the maximum amplitude of the signal at t is equivalent to infinity. So we can say this is also unbounded. Coming to some sinusoidal form of signal, so like this, if you are having like this, so here the maximum may be 1 or 2 or anything, maximum is finite, minimum is 0 or minimum is negative value. So if this is fixed to a reference value, if it is fixed to a offset, then we can say maximum is some value, minimum is 0. But here you are having two-sided signal, minimum is some -1 for example, maximum is +1. Here whatever the amplitudes of this signal is there, those amplitudes are finite. So we can say this is also bounded signal. So the signals in the continuously rising form are said to be unbounded. Remaining signal which are having finite maxima minima are said to be bounded. So continuously rising signals are unbounded. So when you given a bounded signal as input, if you are getting unbounded signal, that means your maxima or minima may be infinite, then you can say this system is unstable system. Then what is the condition for stability means? So if the system is stable, if you given bounded signal, you need to get the bounded signal as output. If you are getting unbounded output for bounded input, then that system is unstable. So this is the first point, a system is stable if its output is bounded for any bounded input. Next, a very important point is a system is asymptotically stable if in the absence of input, if the output is tending to 0 apart from the initial conditions irrespective of the initial conditions, then we can say that is asymptotically stable system. When we can say a system is asymptotically stable system means in the absence of input, without giving input, the system is producing some response which is tending to 0 irrespective of the initial conditions, or is called as asymptotically stable system. Now coming to the third point, a system is stable if its output is unbounded. So this is a system is unstable. A system is unstable if its output is unbounded for any bounded input. So this is the definition for unstable system. A system is unstable if its output is unbounded for a bounded input. Coming to the poles. Poles will define the stability. If all the poles are located in the left half of S-plane, then the system is stable. Stability of the system depends upon the poles of transfer function. So what is meant by poles? What is meant by zeros? You already know about poles and zeros. If you are having some transfer function in A by B form, so the numerator indicates zeros and denominator indicates poles. So whatever the poles location is there, that poles will define the stability. Stability of the system depends upon the poles. How that is dependent upon the poles means, if all the poles are located in left half of S-plane, then the system is said to be stable. For example, if you are having S-plane like this, so this is total S-plane. This is j omega axis and this is real axis sigma. So if all poles located on the left half of S-plane means, so this side, if you are having two poles, that two poles are located on left half of S-plane, then you can say that is a stable system. Then coming to another point, as pole approaches horizon, if pole approaches horizon, the stability of the system will decrease. So for example, according to pole 0 plot, we can say the stability of the system. For example, if you are having two pole 0 plots, two pole plots of two systems, by seeing that pole 0 plot of the systems, you can say which system is much stable. For example, I am having system A and I am having system B. I got my pole 0 plot. So here at -2 I am having pole and here at -1 I am having pole. For system A, I am having only one pole at -2, and for system B, I am having single pole at -1. For example, here you are having -2. Here which system is much stable means, so this system is much stable. Why? Because here the poles are approaching horizon. The poles of system B is very near to horizon. If the poles are approaching to horizon, the stability of the system will decrease. In these two systems, which system is more stable means A system is more stable, because the pole of the system is more away from horizon. So that is the reason. So based on this point, we can say, we can justify the stability of the system according to pole 0 plot. And coming to this point, when poles are located on imaginary axis. For example, here you are having one pole like this. So here I am going to consider another diagram, another S-plane. So if you are having S-plane like this, this is j omega axis and this is real axis, this is totally S-plane. If your poles are located, one of the pole or some poles are located on imaginary axis, then we can say that is marginally stable system. In that justification of marginally stable system also, we need to follow one condition. Poles need to be on imaginary axis and non-repeated. When the poles or when the roots or non-repeated poles are located on imaginary axis, then the system is said to be marginally stable system. Whatever the poles located on imaginary axis, if that located poles are repeated poles, then we can say that is a unstable system. We can't say that is imaginary marginally stable system. If poles are located on imaginary axis and non-repeated, then only we can say that system is marginally stable system. If poles are located on imaginary axis and repeated, when poles are repeated on imaginary axis, then definitely we can't say that is marginally stable system, we can say that is unstable system. That means if you are having minus j and plus j repeated poles, then we can say that is unstable system. So, if different poles are located on imaginary axis, then we can say that is marginally stable system, and definitely the remaining poles, if is there any remaining poles, then that should be on left half of S plane. If at least one pole moved to right half of S plane, definitely we can say that is unstable system. If poles located on imaginary axis are repeated, then the system is unstable. If poles are located in right half of S plane, then the system is unstable system. That means, for example, if you are having poles like this, j omega and sigma, if you are having like this, unstable system. So, if you are having poles like this, unstable system. If you are having three poles, one pole is located left side of S plane, one is imaginary axis, one is right half of S plane, then also this is unstable system. That means if at least one pole shifted to right half of S plane, we can say that is unstable system. So, like this we will define the stability of the system according to pole locations. Poles will define the stability of the system. So, coming to the last very important point, the poles which are close to origin are called as dominant pole. So, here for example, here you are having some, I am having pole 0 plot like this, j omega axis and real axis, and minus 1 and minus 2 or two poles I am having in the left half of S plane. So, here in these two poles, which is the dominant pole, means minus 1 is the dominant pole. How we can say means, according to this point, the poles which are very close to origin or 0 are called as dominant poles. So, here minus 1 is the dominant pole than minus 2. So, this is about introduction for stability. So, stability is nothing but generally you need to get bounded output for a bounded input. If you are getting unbounded output for bounded input, that system is said to be unstable. So, here bounded signal is nothing but the finite values must be there. That means the maximum and minimum value of the signal must be finite. And coming to poles location, so you can justify the stability of the system. So, for a system to be stable, all poles must be on the left half of S plane. If at least one pole reached the right half, then we can say that is unstable system. If any non-repeated poles lies on imaginary axis and remaining poles, if is there any remaining poles, they need to lie in the left half of S plane, then we can say that is marginally stable system. If any poles, repeated poles lie on imaginary axis, definitely we can't say that is marginally stable system. Definitely we can say that is unstable system when poles are repeated on imaginary axis. This is about introduction of stability and stability according to poles location.